Okay, let's go ahead and start. Now, we'll look at monitoring. Means in the daily activities of a WebLogic administrator, especially for those who are supporting production and some of the important non-production environments like training. Monitoring is probably the most important activity that we perform on a daily basis. Means 24/7 somebody is looking at your systems and trying to understand nothing is going wrong. Now the main important thing about a monitoring thing is the alert system. Means you are basically looking at your systems so that things cannot go wrong, or even if things go wrong, you are the one who will know it first so that you can take a corrective action. That's the purpose of monitoring. So by the end of this session you will know certain aspects of why monitoring is required in the first place. Alright, and we will also see commonly asked questions about monitoring, like what do you monitor, what are the tools that you use, what are the various other tools, how do you get alerts, how do you respond to alerts, what will you do when there is an alert, did you configure any monitoring tools, all that stuff. We'll see how to answer those questions also. Then we will see what needs to be monitored basically. Right, we basically monitor if something is going wrong. It can be related to availability or the performance. For example, a server going down is availability monitoring. The server not performing well means the speed with which it's responding is also something that we monitor. The tools that we're going to use and the scripts, if there are any that we're going to use. Then how monitoring scripts are configured in cron tab. A cron tab is something that executes a program at a prescribed time. Repeated means it's a periodic execution. So we'll see how cron tab get used. And then logs of the daily jobs. And we might want to see if there is a cron tab, and if we have scheduled some jobs, how the logs of these jobs would look like. Jobs are nothing but scripts. Means you will have, in a real environment, there will be a lot of activities going on. Let's say every midnight we are loading some data into the database. That's a daily job. The same way there will be other manual scripts that they are all called. Then alert samples, we'll see what kind of alerts you would get, how an alert message would look like. Then we'll also see the questions related to performance tuning or performance monitoring or monitoring simply. Now, first of all, why monitoring is required? Now, monitoring is basically to identify whenever there is a problem. Now, why you want to identify whenever there is a problem? Because problems are the ones that make the user not able to access your system. So before the customer knows, or before the user complains a problem, you want to know about the problem. So that's why you keep monitoring your systems. The monitoring basically is a periodic process. Means, let's say if I ask you to look at the system and make sure it's running fine, you need to keep looking at the system continuously. Now, because manually that's not possible, we use tools to do that checking. So we basically look at systems, we look at log files, look at CPU usage, we look at hard disk usage to understand if there are any symptoms to the problem. Usually before a problem occurs, we have symptoms. Like before you catch any serious fever, you have symptoms. Serious cough, so sneezing, all that stuff basically is a symptom. The same way in a system, anything, if before things go wrong, we will see alerts, we will see things going wrong. That's what we want to catch. And by being proactively monitoring your system, you can actually avoid a serious downtime, because you will take a corrective action before things badly go wrong. Now, not normally, what are the questions you will get in monitoring is, uh, what do you monitor first of all? Then how do you monitor? In other words, what tools you are using to monitor these parameters? You might say, we are monitoring our JVMs, we are monitoring our systems, we are monitoring our databases, we are monitoring our network connectivity, we are monitoring our application URLs. Those are the things that you are monitoring. But how you are doing it? You're using tools to do that. Now the tools are configured. The tools will check manually at every, let's say, 5 minutes, 10 minutes. If there is something wrong, they're going to send you an alert. The tool is going to send you an alert. An alert is an email, or it could be an SMS. These are the two popular alerts. So in your case, you're going to say it's an email alert. So you don't have SMS alerts, let's say. You have email alert. What kind of alerts you get? So that we must have seen in another video. So the kinds of alerts to get, how, what is the email structure of an alert, all that stuff. Now, even Unix, not just the tools, the Unix also can send you an alerts. So using a mailx command, we can write a script, and if the script can be put into a cron tab, make sure the cron tab gets executed, or the script gets executed every 5 minutes. If something goes wrong, we can ask the script to send us a mail. That's a Unix alert. Now the next question is, yeah, good, you got an alert. So let's say you got an alert that a server is down, a JVM is down. Now what are you going to do about it? How will you respond to that alert? What corrective action you will take about that alert? Then the other question is, who supports on-call? On-call is something then you're not in office, your team basically you work from home or something, but in your case you're not supporting any on-call. You will say, we go to the office, so one of us is always in the office, even on weekends and nights also. So we do provide on-call support, but connectivity from home is not there, so we will go to the office. So on-call support is basically the weekend support, what we in our case will say. On-call is when you get a call, you are supposed to respond. That usually happens in some other projects where there is a separate monitoring team. But here, because your team will be doing everything, so the on-call support is basically from the team itself. When somebody in your office gives you a call, then you basically again should go to office and then support. Let's simply say you don't have on-call support, or you have on-call support but you do it from office, whereas your on-site guys have that work from home facility in US, not here. Now coming back, what to monitor is the most important thing. Now when you're monitoring a system and you're trying to make sure things are not going wrong, you basically monitor everything. First thing, application URLs. So that's something that you monitor. Apart from the application URLs, you monitor every aspect of your system. Now remember this order, that remember this list that we are monitoring. You are monitoring application URLs, you are monitoring the system for its CPU and RAM, you are monitoring network for its connectivity. Basically you make sure there is connection between servers. Means all your systems you are able to do a ping, all your systems you are able to do a SSH. That's a network connectivity. Storage you monitor basically if you have enough disk space or not. If there is too much IO activity, then you want to be alerted. So let's say there can be a process which is writing too much data to hard disk. In that case, the system will go slow. Therefore, the JVMs of WebLogic servers running on that box will be slow. Means the users who are accessing or who are hitting those managed servers will experience a slowness, which will result in a complaint. But if you already know about, if you are already monitoring the storage, which means if you are already monitoring the IO activity, you know that okay, there is too much IO, and you can be sure whether the IO is because that you are running something or it's something that went wrong. Based on that, if it is something that you already know, then you can inform the users, yeah, we know this, so this is going to go away in 1 or 2 hours. And if you think this is not supposed to happen, still it's happening, you will take this look at which process is actually doing that major IO. We'll see why it's taking too long or why it's doing too much IO, all that stuff. Then we will see the process itself. And your JVMs, they should be up and running. I usually use a ps-ef grep command to see if the processes are running. The JVM heap uses. Now the heap uses is something that you can see from the console if you are aware of it. Hence, the heap, general heap is XMS and XMX values. Now out of the XMS and XMS, we normally give both of them equal values because as a performance tuning measure, we give XMS, XMX same. Let's say user have given 2048 MB as the total heap size, but is the 2048 MB being used completely? If it is completely being used, then obviously the threads will have difficulty in finding additional space. So you want to know what percentage of your total heap is currently in use, means what percentage of your heap is occupied by the objects. Now if you're, let's say, out of 100, out of the total heap, if 80% is in use, then it's heavy heap uses. The same way it's more like your RAM uses. Let's say you have 4 GB RAM on your system, and out of 4 GB, if 80% is in use, then your system is going to be slow. The same way, JVM heap also, if major percent is in use, JVM is going to slow. So we have a limit kind of thing always. You know, the JVM heap usage should not go beyond 60%, 70%. Then the garbage collection. We want to see when the garbage collection is occurring, how frequently the garbage collection is occurring, what is the GC pause time, ones that we have already seen in the GC viewer and all that stuff. So this is manual analysis. Now the same thing can be actually set up in a tool, and let's say if the garbage collection is taking more than 250 milliseconds, we want to get an alert. We know that in that case, if the GC is taking too long, the pause of the threads is too long, which means the application is going to get slow. Now the same way, the work managers, we can see the load on the servers, the number of requests the work managers are handling. That way we will know how much each instance is actually handling the load. Then if you have JDBC, then there are other areas, JDBC connection monitoring. So connection pool size, how much is the pool size? How much of the total pool size is being used? How many connections are waiting? All that stuff. Then data source status, whether the data source is in active state or it's not active state, it's suspended state, all of that. Then GMS, if you look at GMS, you have queues and topics. So obviously queues and topics need to have messages. So we want to see how many messages are arriving, how many messages are being consumed by the consumers. If the consumer does not consume the message, the queue is going to fill up, which are pending messages. We don't want to have too many pending messages in the queue. If we have too many pending messages in the queue, it means the consumer is not working. Then the bridge. If you have a bridge is a JMS bridge is a JMS implement basically transfers messages from one JMS implementation to other, like WebLogic to MQ. Now when such a thing happens, what do you want to know about it? If the receiver or the MQ is receiving the messages or not. Then the database itself we want to have. This is basically majorly a DBA alert, but we also would like to get some alerts like logs in the database, especially because the logs will create stuck threads. So when there are logs, we want to get alerts about them. So those are the areas, these are the areas where we're going to monitor. We monitor the application URLs, we monitor CPU, RAM, we monitor network connectivity, we monitor disk space availability, IO activity, we monitor the process existence, we monitor the heap usage, the garbage collection, we monitor the load on the JVMs, JDBC connection pools, the GMS pending messages, and then even the application status is something that we monitor. Alright, under JVM, after work manager, you will monitor the application status. Means all the applications have to be in active state. We know that. If the application is not active state, means if the application, let's say, moved into admin mode, then obviously the users will not be able to access it. In such a case, we want to be notified about such a failure. So that's another area, application status. All of them should be inactive. So now you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 areas where you will perform your monitoring. Now repeat this one, make sure you remember this list. These are the 10 areas. The 10 areas that you monitor are these things. Now how you monitor is different. Obviously when you're performing application URL, this is all a manual thing. When you hit a URL, for example, let's say if we log into the server, Okay, I think we're not able to connect. We'll see that one later. So here, let's remember the 10 areas that we are monitoring. Now to monitor, normally any of these monitoring, if we are expected to do manually, that's a problem. For example, if you want to see application URL, the monitoring part, you have to basically execute a ping command to see if the application is accessible or not. Ping, let's say google.com. If it responds, you get, now you basically know that google.com is accessible. The same way you can say you can actually send a HTTP request and check whether Facebook is accessible. The same way your application is accessible or not. Now obviously it's not that every 1 hour you send it. You have to do this checking every 5 seconds. Now that is not possible for a human being. You can't keep checking that page http.com facebook.com is available every 5 seconds. You need a tool to do that. Now the same way, a CPU RAM, you are going to use stop command to check CPU RAM usage, or free-m command to check that. Again, this has to be executed every 5-10 seconds. Then if that's not proper, then you need to send out an alert again. So sending it, checking it is the problem, continuously checking it. Then the connectivity you check using ping commands, SSH command. Then you check storage, you check using df-k, and then IO, you usually use dstat command to find out the IO. The same way process, you will have to do a ps-ef and grep for your Java process. You can have to do ps-ef grep for your HTTPD on some boxes. This has to be done every 5 seconds again. Then a JVM heap size, you need a WLST script that checks the heap size, and this has to be done every 5-10 seconds. The work managers, again WLST script, work managers. Application status, then again WLST script that gives you the application status. JDBC connections, again JDBC connections, how many are pending, how many are in use, what's the current size of the collection pool, what is status of the data source, all are WLST. Then the JMS, again anything related to WebLogic, you basically go with the WLST. Then the database again requires other kinds of SQL queries to monitor. Now the problem with these things is we can't keep executing these commands every 5-10 seconds. So what we do is we use tools to do that. Means a tool does these things. Basically it does the same thing that we do. It has to execute only these commands. See, a tool is not something that is from outer space that does everything or knows everything. A tool is simply the same commands that it uses. We can also use the same things to monitor, but because we can't do it every 5 seconds, we ask the same thing to be done by a tool. Now what tools we use. You can use CS Wiley Introscope, one tool. The other tool that you went through is Oracle Enterprise Manager. Oracle Enterprise Manager, or OEM it's called. Alright, Cloud Control 12C. This is another tool nowadays getting popular. This is not there 2 or 3 years before. So you say that you know Introscope, you say that currently you are working on OEM Cloud Control. There are lots of tools that are Unix based tools. Now, so you are using both Introscope or OEM. One of these two you will say you are using. Let's say you are using OEM. Along with OEM, you have a lot of Unix based scripts that will give you or send you alerts because they get executed from the cron tab. So the tool itself is running as a process, whereas the Unix scripts are getting executed by the cron tab, getting executed by the cron daemon from the cron tab. You'll learn about cron tab and cron daemon in another document. So you have both tool based monitoring and Unix cron tab based monitoring. Now the tools itself are CA Wiley Interscope, and then OEM, and then Unix based scripts also do the same thing. Now in C a while is interscope, the same things you're going to see. So you're going to see the similar things in CS while interscope. I'm going to show you some of what you'll see. In normally uh, when you look at interscope, you will see the login process. There are what are called dashboards. The dashboards are basically the screens where you can see status of server, status of JVM, status of database, status stuff, GMS, anything, application, everything. How do you analyze? We'll see some of this. How do you analyze a dashboard graph? What's an alert on interscope dashboard? Sample alerts. We don't have a proper way to log into these things, but what we're going to do is we will basically see some of the screenshots of interscope. We'll try it. No, we don't have them here. Okay, I'm going to show you some screenshots of the dashboards. So we'll see what a dashboard is, how it looks like. We don't have a proper video for that, live video at least. We'll do it using screenshots. I see this one. This is how you log into Intrascope. I'm going to play this video. This is another video. Basically, I grabbed it from another location.
Now in this video I'm going to show you Wiley Intrascope. Two views here. You can have a web view or the full Wiley GUI. I'm going to show you the full Wiley GUI. So you put in your commonly known password, admin89, connect to the right enterprise manager.
So that is your Wiley login screen.
And render the HTTP for the web pages. So once that comes in, you get two views. You get a console. The screens or the skins that SAP has built. You can see the red traffic lights will tell you if you've got any errors. So we're going to drill down to the host CPU usage here.
That's CPU uses.
Java heap usage. If we scroll down, you can have a look at the screens in use.
Yeah, this is Java heap uses. You see these lines basically. Red line is where they have a problem.
So the triage gives you the most commonly used graphs for debugging errors or just looking at performance. It's just tracking. So here you can see the front end performance. We flick back up to the main screen, and then we're going to drill down into the ABAP triage. So this is showing all my ABAP systems. So because it's quite little, it would be useful. And the updates.
So what you are looking at, so basically whatever you're looking at is, for example, this one here. This is more relevant to us. So you are, first of all, after you log in, when, say this one, this. Okay, a dashboard is something like this. Basically, a dashboard is where you see the overall view of various things in your system. In this case, it's a G2EE overview, like in all the GVMs. You can see the CPU and memory utilization. You can see some of these are relevant. This is not a WebLogic environment. This is more likely a SAP environment. So they can even the SAP actually, let's say there is a Java GVM running. Here also you're seeing GVM GC view. Threads. The same way, if we are working on looking at a dashboard of WebLogic environment, you will see all the parameters that we are trying to monitor here. To look at the 10 areas that we are monitoring, you will be seeing all of them on the dashboard. Now each of them is either green in color or red in color or yellow in color. Green is good, red is something is wrong, and yellow is you need to have attention, or you need to pay attention to what is happening over there. So you keep looking at this dashboard all through the day. Means usually in a support team you have a separate system or a monitor next to you. So everybody in the system is basically, each one of you usually has two monitors in a support system. On one monitor you have a dashboard open, alerts, email alerts open. So whenever the dashboard turns to green, turns to red, ideally you should get an alert also. That's on one monitor, and the second monitor is where you keep working. So what we looked at is the general dashboard, and if when something goes wrong, red or some other color, you can actually click on it and you will go to the actual graphs. So for example, if you click on memory usage, you actually went into the memory usage graph. Now if you see a memory usage graph, so there are various lines here, green line, then there is another line, then there is another line, pink line. These are various metrics you are taking, and the red line that you are seeing is basically the problem is if the usage goes beyond this red line, you basically have a problem. So if you see each of these graphs, these graphs are for different systems. Now there are 1, 2, 3, 4, 5, 6 systems that you are monitoring. On the 6 systems, on one of the systems the CPU is about 90% always. Other system it's 70, it's moving on to 80%, and other system 40. So anything that has beyond this red graph is in alert. So you have these two systems always in trouble. The same way heap uses, you are looking at a lot of JVMs, the heap uses. Just give me one. If you look at this heap usage, so some of the JVMs have like that. If you look at this heap usage of various systems, each line is representing a JVM here. So some of the JVMs have high heap usage, other JVMs have not so high heap usage. And you see this timeline, so you're looking at basically every point represents when the check was made. So whenever there's a point, you see those many checks are being made. And you look at a graph. So when you look at a graph, if you see something is at a very high level, you know things are not good. Now, the same way, there are certain dashboard images that we grabbed. So here if you say this is an image, I'm going to open it in front. This is an image of overall view of your system or all our enterprise. Means how your other servers are connected, what's the status of each of the servers. If any of these things turn to red, then you have a problem. The same way you can, these are routers, the blue ones are basically routers. You will see whether it's up or not. See, this is up, everything it says up. Something is not up, then you will see an alert. Now usually this is a network element, the same way you can actually have for WebLogic servers also. Now this is a dashboard of, see this JVM bytes in use, means the JVM uses. The same way JVM CPU utilization you're looking at. So that's what we looked at, CPU and RAM utilization. And one of our first, this thing, CPU and RAM utilization, that's what you're basically monitoring here. Apart from this, if you go on further, now these are another area wherein there are lots of networks. If you see, so each green one represents one area, so everything is in green, everything is good. If some of the buttons turn to red, you basically click on that red button, see what the problem is. So this is a dashboard again. This is a perfect example of dashboard you see here. This is another dashboard, basically is looking at GMS view. The dashboard basically tells you about how many pending messages, what is the queue size, what's the response time. So forget about the response time, concentrate on the queue size. So if the queue size is within a limit, it will be in red. If the queue size is large, means if the receiver is not receiving, the queue size will increase, which means this will turn into red. Then the listener connectivity also, other things, basically the receivers. Look at the queue size in this diagram. This is another application performance monitor. Enterprise manager health, this is another area where a lot of things, you see this heap utilization is being monitored. Heap utilization means how much heap is currently in use, 1.6k, 1.2, this is 1.6 gigs something. So whenever there is a problem, you will see that error here in this list. Then the GC heap, normally the garbage collection. When the garbage collection is happening and what's the heap usage, because whenever the garbage collection happens, the heap usage will come down because the GC garbage collector will clean up all the dead objects, so the percentage of heap use will be down. So this is a nice graph, see CISA graph. This is a very nice graph, healthy JVM. So if you see that after garbage collection also, if the heap usage is at the top, it means the GC is not able to clean up. So you want to see this thing. Then you'll see GC durations, that's GC pause, CPU uses. If you see this one, there is a spike here at some point when it's at somewhere around 15 hours, the CPU went really high. Otherwise, CPU usage is normal. Then the database disk uses, how much MB is being used. Alright, so these are some of the areas what you keep monitoring. This is another dashboard. This is again looks like another dashboard. See this thing here. You're actually looking at the response time of the servers. Means when you hit a URL, is it responding within 3 seconds, 5 seconds? Now if it should respond within the limited time, if it is not, then you send out an alert. Again, GC heap you are worried about, CPU utilization you are worried about, file IO, socket input available in JDBC pool, idle thread pool count, all that stuff. Everything where there could be a problem, we are monitoring it. See in here. See again, memory usage profile for each server. This is one server, this is another server, this is another server. This is the name of the servers. Look at this one. These are the names of the servers. If any of these things go wrong, this will turn into red. So then you have an alert. Now you know what to do with an alert later. Then it will also show you the JVM thread pool. How many are currently active threads? How many users are logged in? See this here. You're tracking the users also. Then Oracle connections. How many JDBC connections are in use here? Everything you're basically monitoring. This is another thing again. The response time throughput. Response time throughput. This is a nice graph again. Very nice. This is a nice dashboard. So it gives you everything about your system, CPU utilization of the processors. You look at these things, and in a fraction of seconds, you can see if something is wrong. You have a dashboard view of your entire infrastructure. This is another thing. This is a GC graph. This is again a GC graph. How the GC is actually being performed. And what is, see this one? This is a heap size, team seesaw like. See this collection, when the collection is happening. That's it. So these are the dashboards. Well, let's quickly go through the dashboards. These are the dashboards. And through the dashboards, what is that you are monitoring? These are the areas you are monitoring. Alright. So this is the tool. Now using the Unix based scripts also, you monitor exactly the same things. Now there's nothing that the Interscope or OEM tool is doing that we don't know. All those things usually internally use Unix only. If there is a Interscope tool, it still uses stop command to find out what is the current CPU limit, CPU usage. Alright, so the Unix itself can be used to do that, but because Unix is not efficient, you won't get nice graphs and all that stuff. That's why Unix will be used in parallel with the tool. The tool makes it easy to have a look at it and quickly gain knowledge of what is happening on your environment. Now Unix based monitoring is majorly from cron daemon. There's nothing else. It's majorly from cron daemon. Means at periodic intervals you have scripts. You are executing the scripts every 5 seconds to monitor the same list. Same list gets monitored. Because you're already using a tool, you may not be monitoring everything using the Unix. So you may monitor only certain things, like let's say specific disk or a specific JVM that you are monitoring, or the log file. In the log file you want to execute a grep command for any errors, and if there is a problem you want to send yourself an email alert. Now the good thing about Unix script is you can configure it for yourself. Means you can configure a script to send email to only to you. So not necessarily that everybody is monitoring. So usually you have certain scripts that you can monitor and you use for monitoring internal. So in In a Unix based scripting, obviously what kind of Unix scripts you have for monitoring? For that question, you have Unix scripts for again CPU monitoring, RAM monitoring, heap size monitoring. You can give that list, entire list, and some of them skip some of them, and usually use the WLST part, means use WebLogic related monitoring for Unix based answers. And obviously each of those will have a script, and the script needs to be executed at periodic intervals, and the intervals execution is done by the cron tab. So cron tab is the guy who actually executes your script every 5 seconds, and in the script you said if the value is above a particular range, you want to be sending an alert message to your email. What type of jobs? Again, as I told you, all these tools, all these areas that we have listed, 10 areas that we monitor. Some of them will be monitored by Unix. Now, did you write any monitoring scripts? You can say, I've written small monitoring scripts, but there are our environment already has monitoring scripts. We do write monitoring scripts from time to time, so we usually use record button for WLST, or we download it from internet, or some of my seniors write the monitoring scripts. I also written small monitoring scripts. Why do you need Unix scripts if you have Interscope? That's a valid question. Interscope is what overall enterprise monitoring means, your overall system, but Unix scripts are some things that you need from time to time. Means, let's say today, let's say the Interscope is monitoring every 5 minutes, then Interscope is slow in responding, displaying the graph. So, or let's say you don't have something, a new error message that you received today, and you are trying to monitor that error message in the logs. Now, the Interscope cannot be configured because you will not have permissions to configure the Interscope. You will have only a login, just a read-only login. The read-only login will allow you to just watch the dashboard. So whereas the Unix script, you can create a custom Unix script quickly and put up a monitoring whenever it's required. A quick one. Why not do everything with Unix scripts? Why do you need Interscope? That's what Unix scripts. Interscope is basically for the graphs, and apart from the graphs, it also stores the historical data. Means, let's say 1 week before you want to know whether this problem occurred, so you can have a look at the entire graph for the last 1 week. Whereas Unix scripts, it will be difficult to create such a graph. So that's the reason Interscope is what gets used. All right. So monitoring is an essential aspect. The tools that we use are these things. What we monitor is these things. So say it like you basically know end to end of it. All right. Cool. That's the monitoring tool and how we use it, and we actually see in some of the very good Interscope dashboards, and you have also seen a OEM complete video. So that should give you a very good idea about what gets monitored, why we monitor something, and how we monitor things. All right. So let's go ahead and stop it.